Alright, so this lesson here is going to be a little bit of review and some work with parallel and perpendicular lines in particular. Your homework will be posted later. Welcome back. I know you guys are really excited to be back working on math again. Those of you that are actually working, I truly appreciate it. It is very hard to do a bunch of work and then have not a lot of people do it, but I'm here for you guys and I promise I'm trying to help you out. I will be trying to also get on to WebEx several different times a day. I'm trying to be as flexible as possible and try to go all over the place just because some people are just not signing on during the normal class time, and so it's just easier that way. I know it's not easy on everybody that way, but I'm trying my best to get as many possibilities out there for you to learn the material and be ready for your next class when you get into intermediate algebra. So, like I said, welcome back. I'm glad to have you guys back here, and I'm glad to be working on some math with you again. So what I have today, like I said, is a little bit of review of writing the equations of lines, some stuff that we did before the break. So, specifically, we're also going to look at parallel and perpendicular a little bit more today. So number 1, number 2, number 3 on the screen here, you may want to pause it and try them first. That way you can actually practice what we did before spring break. After you've paused it, you should be able to now see the answers and go through the answers with me. Before the break, we talked about writing the equations of lines, and we talked about specifically that form called slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept, the beginning amount and what it moves by in real life. And so what we talked about is we can use that form to find equations of lines with different amounts of information given to us. Particularly in number 1, we have the point -5, 4, and we have the slope is equal to 2. So if we're thinking about that y equals mx plus b, we have the m, it's given to us. M is 2. But we don't have the b. We don't have the y-intercept because this right here, -5 and 4, is an x value and a y value, x1 and y1, from a particular point on the graph. It is not the y-intercept. Remember, the y-intercept would always have a x value of 0 if it was the y-intercept. So what we have is we have a point and a slope. So what we can do is we can find the b by plugging in these numbers into the spots in this equation and solving for b. We know that m is 2. We know that the x value from the equation, or the point that we are given on the equation, is -5. We know that the y value is 4. And now we can use this equation and solve for b. What is 2 times -5? Well, 2 times -5 is -10. And how do I get b? I solve for b by adding 10 to this side, adding 10 to this side. 4 plus 10 is 14. So that is my b value. So what is my m? My m is 2. What is my b? My b is 14. So my equation for my line would be y equals 2x plus 14. M is 2, b is 14. There's my equation of my line. And that's what we did before the break, was we found different ways to find the m and find the b. And so what we're going to go through today is just practice that several more times and specifically look at parallel and perpendicular lines a lot more than we did before the break. Next class, we're going to do this again, but we're going to be doing it with data points. Specifically, you guys probably have heard of something called a scatter plot before and a best fitting line. We're still going to be writing the equations of lines, though. So here we go. Let's take a look at another example. Number 2. Parallel to y equals -3x minus 3 and passes through 2, 1. So we want to find the equation of the line, again, y equals mx plus b, and it's parallel to this line, and it passes through this point. So again, we have a point, an x value and a y value from one point, x1 and y1, from a single point on the graph. That's not the b. We also don't see anywhere in this problem where it says the m equals. Like we did in the last problem, it was very equal, m equals 2. But if you look at this word right here, this is the key, and this is why we're doing this little review specifically to talk about parallel and perpendicular. Parallel lines, remember, are two lines that do not touch each other. And so therefore, if you have two lines that don't touch each other, the slope would have to be the same. That whole rise over run would have to be exactly the same for both of them. That is the only way possible that you can have two lines that don't touch each other on a graph, is if their slopes are the same. So what does that mean? That means right here, the mx plus b, that -3 right there, that is my m. That is my slope. But don't use this b, because this is a totally separate line. This line is -3x minus 3. It has a y-intercept of -3 and then a slope of down 3 over 1. This line is not the line I'm looking for. I'm looking for another line that's up here at 2, 1 and has the same slope down 3 over 1. So I'm looking for a different line over here on my graph. I'm not looking for the same line. I'm looking for this one, not this one. So what I want to do is I want to do the same thing I did on the last problem just a minute ago. Now I know -3 is going to be my m. My x value is 2 from the point. My y value is 1 from the point. And now I can find b. What is -3 times 2? -6. What do I do to get b by itself? I add 6 to this side and add 6 to this side. 1 plus 6 is 7, so b would be 7. So that means y equals -3 is my m, plus 7 is my b. That would be the equation for this line right here. It should be crossing the graph somewhere up here about 7. And I know I didn't draw a perfect graph, but that would be my new line. So when you're doing a parallel line or a perpendicular line, we'll talk about in a second, you have to remember that it's not the line that you are given that you're finding. It's a new line that's parallel to that line. Or, in the case of perpendicular, we'll talk about it. The last type of example that we looked at before the break was what happens if you have 2 points on a line and you need to find the equation of that line. Specifically, this is going to tie very closely to more real-life situations where you have two pieces of data. 5, -2 would be about here. 8, -3 is going to be about over here. And you've got to find the equation of this line so you can then make predictions. Or you've got a computer that's spitting out these numbers, and you have to figure out, what is the computer telling you? What is it telling you about what's happening in your machinery that you're working with at work? You've got to make predictions about that. That's what these equations do, is they help me make predictions. The difference is now you have 2 points. You have x1 and y1, and you have x2 and y2. You don't have m, and you don't have b. You don't have either one. So we need to find both of them. So specifically, we want to find first the m. We want to find the slope first. So back well before the break, and multiple times right before the break, we talked about this old slope formula, y2 minus y1 over x2 minus x1. So we take and we do -2 minus -3 over 5 minus 8. Now, it really doesn't matter what order you do those, as long as you start with the same point on the top and the bottom. So y2 minus y1 over x2 minus x1. Also make sure that you do the change in y's over the change in x. So -2 minus -3 is the same thing as -2 plus 3, which is 1. 5 minus 8 is -3, so that is -1/3 is my slope. If you look over here at the sort of sketch that Mr. Harrison drew, it should make sense. Down 1 over 3. That's what we talked about with the rise over run, the slope. So there's my m, but I still don't have my b. So then I just go back to the same thing I did here, the same thing I did here. If I have one of these points, I can choose whichever one I want, and I have the slope, now I can find the b. So I take my y equals mx plus b, and I plug in my m, we just found it, -1/3. And then I pick a point to plug in for x and y. Now it doesn't matter which point. You can pick either point that you would like. So if I plug in 5 for x and -2 for y, I can find my b now. So that's going to be -1/3 times 5. That's -5/3. You can use your calculator to help you out. I'm just trying to save a little bit of time on the video. You add 5/3 here, add 5/3 here, very similar to what we did just a minute ago when we were finding the b. So you have -2 plus 5/3, or -6/3 is what 2 really is, plus 5/3, so it's -1/3. And that's actually where this graph would end up crossing right here if you extended it out. I know I didn't draw that very well. It would cross at -1/3 for my y-intercept. So my equation of this line is y equals -1/3 x for my slope and -1/3 for my b. That doesn't always happen where your m and your b are the same thing, but it just happens in this particular problem. So this is what we did before the break. We talked about finding the m and finding the b to find an equation of a line. So specifically, we're going to go into, okay, let's talk about what that looks like when we're looking at parallel and perpendicular. Let's do that a couple more times. And then we're going to do a couple little word problems too. So it says, write an equation of a line that is parallel to y equals 2/3 x minus 2 and passes through the point -2, 1. So again, remember, what does parallel mean? That means it's two lines that are going up 2/3 that have the same slope. But you got one of the lines, you want to find the other equation. So be careful. What it means is my slope is going to be the same, but nothing else is going to be the same. Okay? So try this one on your own. Pause the video and try it. After you've tried it now, my m, like I said, is 2/3. That's my slope. Because it's parallel, it has to have the same slope. That's what that means. And it passes through this point, -2, 1. So my m and my, I don't have my b, do I? So I use my equation again to find it. That y equals mx plus b. I plug in my m is 2/3. I plug in my x value. I plug in my y value. And then I find what b is. So 2/3 times -2 is -4/3. I add 4/3 here, add 4/3 here. If you do that, that is going to end up giving you 7/3. Yes, that's 2.3 is a decimal, and that's okay. I'm not extremely opposed to decimals. Just remember, I usually try to use fractions because they're more precise, they're more exact. So my m is 2/3, my b is 7/3. There's my equation of my line. All right, so let's do this with perpendicular. Perpendicular in particular means that you have two slopes that are not parallel. They are intersecting at a right angle. I didn't do a great job of drawing that, and that's still not great. Oh goodness, we'll get it eventually. That's close enough. They meet at a right angle, which means they do not, they are going to touch, excuse me. It's not parallel lines. That means they do not have the same slope. One of the slopes, obviously, if you look at this, hopefully you can see, is going down. The other slope is going up. And they're going to be opposite and reciprocal. What that means is you have a really flat line going this way. The perpendicular line is going to be really steep going the other way. Opposite and reciprocal. So the opposite and reciprocal of -1/3 would be +3/1, or 3. So if you have a line that's going down 1/3, really, not very steep at all, and then you have a perpendicular line that's going up 3/1, that is going to be a steeper line going up. So it's opposite and reciprocal. 4/7, opposite and reciprocal, would be -7/4. -9, opposite and reciprocal, would be positive 1 over 9, because it's 9 over 1 in case you didn't know. So perpendicular means the slopes will be opposite and reciprocal of each other. So anytime you want to find an equation of a line that's perpendicular to something else, you use the slope and you use the opposite and reciprocal slope. So I'm going to have to kind of just write my own little example of this. Let's go to this page here. So let's say I have a line y equals -1/2 x plus 3. That's approximately going to be a line that looks sort of like this. And I want to find the line that is perpendicular to this. So perpendicular to this line. And I want it to, find a line that crosses through the point. We'll use something sort of simple down here. We'll say it's going down through -2, -2. So we're going through this point, and I want to find the line that is perpendicular to the original. So I'm trying to find the line that's going to go up through here like this, and it's going to be perpendicular. It's going to be forming a right angle right there, a 90-degree angle. So it's perpendicular to this one going this way. Well, how do I do that? Well, what's the slope of this line? -1/2. It's going down 1 over 2. But if it's perpendicular to this line, I don't want to use that line. I'm not going to use -1/2 as my slope, because that is not what perpendicular means. Perpendicular lines do not have the same slope. They have opposite and reciprocal slope. So what's the opposite of -1/2 and reciprocal of -1/2? So opposite and reciprocal would be positive 2 over 1, or just 2. That's my slope. And if you look at this little red dashed line that I sketched, it's going up 2 over 1, up 2 over 1. That does make sense. It's not perfectly drawn. Okay? So, what's my B then? If I know my M is 2, what's my B? Well, I've got a point, -2, -2, but I don't have the B value. I don't know where it crosses the X or Y axis, excuse me. So this right here is my X1 and Y1 like I used before. So I use my Y equals mx plus b, and I find my B. So my M, because it's perpendicular, has to be opposite and reciprocal to. My X value from the point is -2. My Y value from the point is -2. And then I'm going to find B. 2 times -2 is -4. And then I take this right here and I do +4 plus 4. That's going to give me 2 is B. So there's my B. I didn't mean for that to happen because I just made that one up on the fly. It ends up being the same equation, or same M value and same B value again. So Y equals 2x plus 2. That's my equation of this line right here. So with parallel lines, you take it and you use the same slope that's given to you and the point to find your B. With perpendicular lines, you use the opposite and reciprocal for the slope. So you can watch this video several times. I believe I even have another video on my YouTube channel, if I'm not mistaken, that's specifically for parallel and perpendicular lines. Or you can just search them on YouTube or search them on Khan Academy or something. You can find several examples of that probably on your own as well. So the last thing that we're going to do today is we're going to look at a couple of problems that are word problems that deal with these equations of lines. Specifically, I'm going to use this first example up here. And second example, let's give myself a little bit of space there, and we'll use both of them. All right, so let me zoom in a little bit here. Hold on just a second. There we go. That'll make it a little bit easier to see. In March, Joe had $250 in his savings account. In September, he had $460 in the savings account. Write an equation of the line and then find out how much Joe will have in December. So what I want you to do is I want you to go ahead and try and see if you can do it on your own, and then unpause the video. So in March, Joe had 250. In September, he had 460. That, guys, right there is 2 points, just like we had just a little while ago. March is the third month. He had $250. September is the ninth month. He had 460. Now we can use these 2 points to find my slope, y2 minus y1 over x2 minus x1. Let me pause right here for a second and tell you how I know that the money is going to be the y's and the months are going to be the x's. Because typically when you're talking about money to somebody, you're going to be telling them how many dollars per month you're gaining, not months per dollar. That sounds kind of dumb. So you're typically going to have the change in dollars over the change in months, or change in y's over change in x's. That's how I knew my y's were my dollars and my x's were my months. So 460 minus 250, I'm going to end up with 210. 9 minus 3 is 6. So 210 over 6. If I were to take 210 and divide that by 6, that's going to tell me 35. That is my M. Now, what does that mean in real life, though? That means dollars per month. That means old Joe here is gaining $35 per month in his savings account. Now, we can write an equation that can be used to find out any amount of money that you wanted to have in Joe's account. Still using that y equals mx plus b thing we talked about before. So my M is 35. My x, I'm going to use this point here, is 3. My y value is 250. And what is 35 times 3? Well, 35 times 3, that's going to be 105. And 250 here. Subtract 105, subtract 105. 250 minus 105 is going to be 145. That's my B value. So what would my equation be? The money in Joe's account, the Y value, is equal to $35 times each month plus 145. Now, what does that 145 recognize for us? That tells us that at the beginning of the year, that means before January, Joe already had $145 in his savings account. That's important to know because it can mess you up if you're not careful when you're trying to, make decisions about your money. If this was really you, if this wasn't Joe, if this was Mallory or Olivia or Joey or, Aubrey or JC or whoever, whoever this is, Blake, who's probably asleep right now, probably not watching the video, right? But anyways, that would tell you, how you can make decisions about how much money you're gaining each month, how much you started with, how long is it going to take me, how many months is it going to take me. You'd have to go into multiple years if you were trying to get thousands of dollars, right? But now we can also figure out how much Joe has in December by taking this equation and plugging in 12. So we can take our calculator and do 35 times 12 plus the original 145. And that means Joe has $565 in December. All right, so I want you to use the same concept and take a look at this particular equation. This one's going to be a little bit uglier here. Try to do this one. Try to pause the video and do this one. By the way, I want to apologize for the sound I've got. If you hear the washing machine going in the background, I apologize. In 1990, 54% of all music was sold on cassettes. By 2000, only 5% of all music was sold on cassettes. You guys probably don't even know what a cassette is, but write an equation for the line using percent in terms of the year. I told you about this little phrase earlier in the school year, earlier in the classes too. When you have in terms of, the Y value is typically before that, and the X value is typically after that. So that helps me out here because that helps me to set up my 2 points just like I had before. So in 1990, 54%, that's my Y value. In 2000, 5%. Now, why didn't you put the years in, Mr. Harrison? Well, because I am going to try to simplify things for you a little bit here, make the numbers not be quite so ugly. 1990, instead of putting that in for the actual year, I'm going to put 0. I'm going to make 1990 be the beginning year. And then 2000 is 10 years later. Now, what I need with that is I just need to remember when I'm talking about this equation that 0 is 1990. And that's important to remember. You could actually use 1990. The tricky part with that is that it would be saying the year 0, literally the year 0 would be 0. And so that would cause a really ugly beginning amount, or y-intercept. So let's find my slope, just like I did before. 5 minus 54 over 10 minus 0, or y2 minus y1 over x2 minus x1. 5 minus 54 is negative 49. 10 minus 0 is 10, so that's negative 4.9. What that means is, if you're looking at the percentage of music that's sold in the U.S., each year the cassette percentage was going down by 4.9% each year. And that should make sense. As technology increased, less and less people used cassette players. So that's my M. Now here's the other cool thing about making 1990 the beginning year. That means that this right here is the beginning amount. Or in other words, 54 is my B, because that means my y-intercept is up here at 54. 0, 54. So my slope is negative 4.9 over 1, or down 4.9 over 1, or down 49 over 10. And then my B value is 54. So now I already have my equation. Y equals negative 4.9x plus 54 for my beginning amount. I didn't actually have to do a whole lot of work to find my B value because I made 1990 be the beginning. All right, so that's a little review of a lot of the stuff that we've been doing before the break, writing those equations of lines, finding the M and finding the B. I will be posting your homework later. I obviously want you to watch this video first, so hopefully you watch this video before you do your homework.